Now before lesson 1-5, we're going to do this little add and subtract fractions review. So for our first problem, we're going to add 2/7 plus 3/7. They're already common denominators, so we're going to keep our denominator 7 and just add 2 plus 3 is 5. We can't reduce this, so this problem's finished. Example 2, 5/6 minus 1/3. Notice that these fractions do not have the same denominator. So we're going to rewrite them with the same denominators. So we're thinking of a number that is a multiple of both 6 and 3. Well, since 6 is a multiple of 3, as in you could say 3 times a number to get 6, then we can use 6 as our denominator. So 5/6 will stay the same. But we'll have to think a minute about this 3. 3 times what is 6? That would be 2. So we gotta do the same thing to the numerator to make equivalent equal fractions. They have the same value. So 1 times 2 is 2. So 1/3 is equal to 2/6. They have the same value. Now we have two fractions with the same denominator, and we are ready to subtract. So we keep our denominator and just subtract the numerators. 5 minus 2 is 3. We're almost finished with this problem, but this problem can be reduced. So we think of what will 3 and 6 both divide by? Well, they'll both divide by 3. So we get 1/2. For example 3, we have 2 1/5 minus 4/5. This is bringing in a mixed number, 2 1/5, where you have a whole number or an integer followed by a fraction. And these are already with common denominators, but we do have a little problem. We can't say 1 minus 4. We could think back to our integer rules, but that gets more complicated than would be useful here. So we're going to need to borrow from our whole number 2 to make this fraction 1/5 have a larger numerator. So I'm going to start, same concept as when you're just subtracting numbers and you have to borrow from another place value. We're going to borrow 1 place from the 2, so it becomes 1. So when we borrow that 1, we're going to add it as 5/5 because we're dealing with fifths. So I'm going to add 5/5. So what I end up with is 1 6/5 minus 4/5. And we can subtract now. Our whole number, 1 minus 0 is just 1, and then subtract our fractions. 6/5 minus 4/5 is 2/5. Example 4, we have 3 7/8 plus 2 1/6. So you'll notice that we have mixed numbers that we're adding, and they have different denominators. So we'll start out by getting a common denominator. So I can just rewrite my problems, and I'll leave the fraction portions blank for the moment, and I've got to think of a multiple of both 8 and 6. I could always go over to the side and figure this out. I'm thinking of multiples of 8 and multiples of 6. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. So multiples of 6, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. You'll notice they both have a multiple of 24. So I'm going to use that as my common denominator. And then we have to look back and figure out our numerators because we need an equivalent fraction to 7/8 with a denominator of 24. So 8 times what is 24? That would be 3. 7 times 3 is 21. And then 6 times what is 24? That would be 4. So 1 times 4 is 4. So now we have fractions that have the same denominator, and we're ready to go ahead and start adding. So we add our whole numbers. 3 plus 2 is 5. And then we can add our fractions. They have the same denominator, 24, so that means we can add them. And the numerators, 21 plus 4 is 25. I can't leave my fraction written that way because 25/24 is an improper fraction. But I could go to the side and recognize this, that 25/24 is 24/24 plus 1/24. And I'm saying that because that tells me that it's equal to 1 and 1/24. And we could just rewrite that as 1 and 1/24 this way. And then just add it to 5, the whole number that we have in the problem. And that gives us 6 and 1/24. And now we've got it written properly as a mixed number. Okay, so I'm going to let you try a couple of problems. Just add or subtract whatever the operation is in the problem. And take just a few minutes to work these out. And then you can come back here, pause the video, come back and check your answers in a little while. Okay, so for our first problem, we're adding, but we have different denominators. So I want to rewrite this with the same denominators. Notice that you have 9 and 3, and 9 is a multiple of 3, so we can use 9. Our first fraction is 8/9, so we can just leave it as is. It's equivalent because it's got the same denominator. It's actually the same fraction. And then our second fraction, 2/3, we can write with an equivalent fraction with a denominator of 9. So I'm going to think about 3 times what is 9? That would be 3. And 2 times 3 is 6. So then we're ready to add. We have the common denominator of 9, and we add the numerators. 8 plus 6 is 14. So we're almost finished. Sometimes you are finished at this step, but this is an improper fraction, so we have to rewrite it. And we can do this by saying, how many times will 9 go into 14? It will go into 14 one whole time with 5 remaining. So we get 1 and 5/9. For our second problem, we are subtracting mixed numbers. Let's start with getting a common denominator. So I have 4 and something minus 1 and something. And we need a denominator that 2 and 7 will both go into, a multiple of both 2 and 7. You could go to the side and sketch out your multiples of 2 and your multiples of 7. You would find very quickly that a multiple of 7 is 14, and that's also a multiple of 2. So we can use 14. And then we'll think about equivalent fractions. 2 times 7 is 14, so 1 times 7 is 7. And then 7 times 2 for our other fraction is 14, so 5 times 2 is 10. We could subtract, but right now we would be subtracting 7/14 minus 10/14. So we need to make this a little bit easier. So I'm going to borrow over here at this 4 and 7/14. I'm going to borrow from 4 and make it a 3. And then I'm going to add to 7/14. I'm going to add an entire 14/14. and I might show that over here on the side. So I'm going to end up with 3 and 21/14, because when I borrowed one whole, I just wrote it as the fraction 14/14, which is still one whole that was added to 7/14. And then we are going to subtract 1 and 10/14. We're ready to subtract. Our whole numbers, 3 minus 1 is 2. And then we have a common denominator, 14. And our numerators, 21 minus 10 is 11. We can't do anything else to reduce or simplify, so we're finished.